next category of tissues is connective tissue, and this is the largest category, even though it feels like epithelial was really long. And in this category, you kind of sometimes get lost and forget that you're still in the category of connective tissue because some of the tissues don't feel very connective. So we just be careful and just realize that this is a big category and has lots of different types of tissues all put into this category. So it's a type of tissue where the cells occupy less space than the extracellular material or the matrix. So you'll expect to see some kind of blank space or some fibers in between cells, and it's not just cell, 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 cell. This type of tissue binds organs to each other and also supports and protects those organs. And most of those cells in the connective tissue don't directly touch each other. They have that matrix in between. This type of tissue is highly vascular, so that means it has lots of blood vessels supplying it, and it is the most abundant type of tissue, widely distributed all over the body, and it is variable, so that means it's going to look different. The different types of connective tissue are not going to look similar to each other. The functions of connective tissue is quite a long list, and that's because the connective tissue has so many different types. So some connective tissue is binding the organs, those tendons and the ligaments. Some connective tissue is supporting. That would be an example of bones and cartilage. Physical protection, immune protection. You don't think of connective tissue as blood, but blood does fall into this category, which also includes a function of transport. And bones are also in this category, so that means one of our functions for this category has to be movement. And then you see storage and heat production as well. Okay, so here's everything that fits into this list or this category of connective tissue. So 4 types are considered fibrous. You may see the word fibrous with them, you may not. So you may just see it say connective tissue, and that's why it says or connective tissue proper. And then there's 3 types of cartilage, and then adipose, bone, and blood don't look like anything in those other 2 categories. So it is a widely variable group. So we're going to list the types of cells, and I find this list to be a little bit premature only because not all of these connective tissue types are going to have these cells. So to me it feels a little bit weird to talk about each one. In the lab, I would definitely just focus on the types of cells that you see slide by slide. I wouldn't try to memorize this list altogether because it feels a little weird. I think it would make way more sense to, as you go through the lab, to memorize what types of cells are in each type of connective tissue. But here are some that you would expect to see. Fibroblasts are cells that produce fibers. Macrophages are cells that use phagocytosis on foreign materials to get rid of them. They also activate the immune system when a foreign matter is sensed. These macrophages come from white blood cells, and we'll talk about white blood cells here because blood is a type of connective tissue. You will see leukocytes or white blood cells, and then it talks about 2 specific types of those. Plasma cells help synthesize disease-fighting antibodies, so they come from lymphocytes, which are white blood cells. We'll see mast cells that secrete heparin and histamine. They are alongside the blood vessels. And then we'll see adipocytes, which are fat cells, and they store fat molecules. We'll also see fibers in a few of these types of connective tissue. They'll usually look like long lines, and so the most abundant type of these fibers are collagenous fibers. They make up 25%. They are very tough but also flexible and resist stretching. They're less visible. It's going to depend. They're less visible in cartilage and bone. We will see them in the areolar tissue. And then other reticular fibers are much thinner. They almost look like little skinny wavy lines, and they provide the framework for organs such as the spleen and the lymph nodes. We'll also see elastic fibers that are thin as well, and they kind of branch. So we'll see those in the areolar tissue, and they are made of a protein called elastin. I'm going to skip through this part talking about ground substance. I think that there's plenty to talk about in this chapter, so I'm going to kind of fast forward through those. Our fibrous connective tissue can be broken up into kind of subcategories. Now, there's only 4 types of fibrous connective tissue, so you may not feel like they need to be broken up into categories, but they are. So, loose connective tissue is areolar and reticular are considered to be loose. Areolar is going to make sense when you see it, but it just means that the space in between the cells has that gel-like ground substance. And so for you looking at the slide, it may look blank or clear. Whereas dense connective tissue, the fibers fill the space in between the cells. And what you will see is lots and lots of fibers. So that is dense regular connective tissue and dense irregular connective tissue. Okay, so here we go with each type. We'll talk a little bit about it and have a picture. And again, these are the types that you're going to be working through in the lab. So the first and probably the easiest to recognize is areolar tissue. It's very loosely organized fibers, has lots of blood vessels, and it seems like a lot of empty space. Sometimes this is just called loose tissue, sometimes, but it is technically called areolar. It has lots of different cells. It has all different cell types, 6 different cell types in there. And this is found in tissue sections from almost all parts of the body because it surrounds all of the blood vessels and nerves. So that makes sense that we're going to find it everywhere. And nearly all epithelium rests on a layer of areolar tissue. And there it is. So you can see the cells. You can see the fibroblasts are the easiest to see, but it does have different types of cells and then all of those fibers going every which way. So for each of these, you definitely want to make sure that you can identify it just by the picture, and then in your lab you'll also have certain features of each tissue that you should be able to recognize. So in this one I would guess that it would be the fibers and the fibroblasts because those are the most obvious. Okay, next is reticular tissue. Reticular tissue kind of looks like areolar, except that the fibers are more wiggly. They are reticular fibers. And then you can also see in this picture, you can see some leukocytes. It forms the framework for lymphatic organs, so the lymph nodes, the spleen, the thymus, and bone marrow. Here's your dense, regular connective tissue. It is very dense. So those collagen fibers are packed in there real tight. You can see the nuclei of the fibroblasts, but it's weird because they don't look anything like the fibroblasts in the areolar tissue. They are very packed in there, and you see this in tendons that attach muscles to bones and ligaments that are holding bones together. Dense, irregular connective tissue, I think, is one of the harder ones to identify. Kind of looks like a mess. But it is densely packed collagen fibers. They're just not all in a cute little row like the regular tissue. And there's very few visible cells. So on this type of tissue, you probably wouldn't be labeling cells, but there are fibroblasts in there. That's what those dark purple nuclei is. This type of tissue withstands unpredictable stresses. It's our deepest layer of skin, and it capsules around organs. The next type of connective tissue is adipose tissue, which sometimes is called fat, but it is where the adipocytes are the dominant cell type, and those cells hold or store fat molecules. The space between those cells is occupied by areolar tissue, reticular tissue, and blood capillaries. But when we look at it, we can't really see much going on. We just see those big adipocytes. We know that fat is the body's energy reservoir or long-term energy storage. And it does provide thermal insulation and cushions our organs and contributes to our body contours. Thank goodness for that. On average, women have more fat than men, and too little fat can reduce female fertility. Most adult fat is called white fat. That's the type that you will see. There also is a type called brown fat in fetuses, infants, children, and animals that hibernate. And on the left is what you will see in the lab if it's stained. Sometimes adipose tissues slides are not stained so darkly, and it may look very, very faint. So the boundaries between each cell may look very faint. It might not look as dark as this one. So they are empty looking cells with very thin margins, so they're kind of packed in close together. And the nucleus is up against each cell membrane. It's not in the middle where you would expect it to be. Again, energy storage, insulation, and cushioning. I'm going to save cartilage and the rest in the next video.